Good afternoon, students. A warm welcome to lecture 50 of fluid mechanics. So, we have successfully completed 3 units, and we have discussed a variety of problems and derivations among all the 3 units, that is, unit 1, 2, and 3. So, in the unit 1, we were discussed about the properties of fluids. Unit 2, we were discussed about the types of classification of fluid flows, and the unit 3 were discussed about the laminar flow and the turbulent flow. So in this class, we'll see about the important formulas that we have encountered till these 3 units. So in this session, I will say about the formulas, what we have come across, and what are the problems we have done with these formulas. We will discuss unit by unit, right? So I will I will show the unit 1 details, and I will show what are the formulas we have used in this unit. Like this, we have 3 units in this session, so that in this class we will complete all the 3 units in brief, right? Only the formulas, right? Yes. So if you see here in the unit 1, we come across, we are having dimensions and units. Okay. So in this unit 1, we will get majority of uh, what majority of 50% problems and 50% theory. Okay, so we'll get 50% problems and 50% theory. So why? Because you are having equal percentage of problems and also equal percentage of theory, so that you are getting both theory as well as problems, right? Theory and problems, right? So if you see in the unit 1, you are having the dimensions and units. So what are the various physical properties of the fluids, that is the specific gravity, the viscosity, the surface tension, and the vapor pressure. So based on this, we are having some of the formulas also for this topics, and also how these properties have been influenced on the fluid motion and a pressure at a point in a fluid. And we are discussed about the introduction to the Pascal's law, right? And in this Pascal's law, you are having a formula also, so that we have derived and we have used those formula for some problems. And also the next one is a hydrostatic law. So in this hydrostatic law, we are having the derivation and also the problems, right? So we are having theoretical concepts like atmospheric gauges, vacuum gauges, pressure gauges, and measurement of pressure. How to check the pressure in a fluid and what are the various devices, how to measure those things. And we are having the various types of pressure measuring devices, that is mechanical pressure devices as well as optical pressure gauges. So we are having mechanical gauges, optical gauges. Next, coming to the manometers. Next one is manometers. What are the various types of manometers, right? What are the mechanical manometers? What are the optical type of manometers? In this mechanical, again, we are having various types of manometers. Those are differential manometers and micromanometers, right? So we are having differential manometers and micromanometers. Next one is hydrostatics concepts. In these hydrostatic concepts, hydrostatic forces on submerged plane, right? We are having hydrostatic forces on submerged plane. Next one, we are having horizontal plane. We are having vertical type of plane. We are having inclined type of plane. We are having curved surfaces. So we have already derived the derivations and we got the formulas, and also we have completed the problems also based upon this hydrostatic forces, where you are having submerged plane, horizontal plane, vertical plane, inclined plane, and the curved surfaces. And also we have seen the center of pressure in a fluid flow of any type of container. Okay, so like this we have discussed all the topics, right? So we have discussed the theory, we have discussed the problems also. Next, coming to the formulas and some of the single sentence definitions which comes in the part A, that is the question paper local, your main external question paper, you are having part A and part B. So in the part A, you are getting small questions, right? 2 marks and 3 marks. In the part B, you are getting 8 marks, 7 marks, like this. 15 marks problem you are getting in the part B. 2 marks, 3 marks you are getting in the part A, right? So if you see some of the formulas and also one-line definitions, the weight density or specific weight of a fluid is equal to the weight per unit volume. It is equal to weight is equals to rho into density, rho into specific gravity G, right? Rho is equals to 1000 for water, and rho value is some other number for oil or other viscous fluid, and G is equals to specific, the 9.81 meters per second. Next one. The specific volume is a reciprocal of mass density. So what is the specific volume here? It is a reciprocal that is one by the mass density. Okay. Next. The shear stress is proportional to the velocity gradient, that is du by dy. Therefore, mathematically we can write shear stress tau is equals to mu into du by dy. That is a shear stress formula. Shear stress is equal to proportional to the velocity gradient, that is tau is equals to mu into du by dy. Next, kinetic viscosity V. So the notation is kinetic viscosity V is given by V is equals to mu into rho. Mu V is equals to mu into rho. Next one. The poise and strokes are the units of viscosity and kinetic viscosity respectively. So for a viscosity and kinetic viscosity, what are the units here? The units are poise and strokes. Next, sixth one. To convert the unit of viscosity from the poise to MKS units, the poise should be divided by 98.1 and to convert poise into SI units. So there's other thing. For a perfect gas, the equation of the state is small p by rho, that is equal to RT. There where R is equals to gas constant and for air is equals to 29.3. Then for isothermal process, P by rho is equals to C. Whereas for adiabatic process, P by rho K is equals to constant. So like this, we have seen some of the statements in the unit 1. Next, if you see the formula for bulk modulus K, we have done some problems also. K is equals to minus dou P by dou P by P. Compressibility is the reciprocal of the bulk modulus, means 1 by K simply. So what is the bulk modulus? This is the formula for the bulk modulus. And what is the compressibility? Just 1 by K, right? 1 by K. Next, surface tension definition, surface tension. So this is a compressibility definition. This is a bulk modulus definition. The surface tension is expressed in newtons per meter. The relation between the surface tension sigma is equals to the difference surface tension and the difference of pressure P between the inside and the outside of the liquid drop is as given as P is equals to 4 into sigma divided by small d. For a soap bubble, small p is equals to 8 into sigma divided by d. For a liquid jet, small p is equals to 2 sigma divided by d. So these are some of the statements. Whenever you get any problems related to soap bubble or liquid jet, you have to use the value of p is this one. For a normal liquid drop, that is 4, we have to keep. For a soap bubble, you have to keep 8. For a liquid jet, you have to keep 2. That's it. Okay, now next. For the capillary rise in a tube, capillary rise or fall in a liquid is given by H is equals to 4 into sigma into cos theta divided by W into D. The value of theta for water is taken as equal to 0 and for mercury is 128 degrees. These are some of the statements and units whenever you are taking specific things. There is a mercury, soap bubble, water, oil, like this, right? Next. Next definitions are the pressure at any point. Okay, the pressure at any point in a fluid, the pressure at any point in a fluid is defined as the force per unit area. Okay, The pressure at any point in a fluid is defined as the force per unit area. Okay, now the Pascal's law states that the intensity of pressure for a fluid at rest is equal in all directions. So we have used some of the triangle thing, right, for to derive the Pascal's law. So we have used this one and we have solved the derivation. The fluid in rest is equal to intensity of pressure is equal in all directions. So this direction we have took a small element in the fluid like this, right? Next one. The pressure variation at any point in a fluid is rest is given by the hydrostatic law, which states that the rate of increase of a pressure in a vertically downward direction is equal to the specific weight of the fluid. That is a formula. W is equals to rho into G. Next. The pressure at any point in an incompressible fluid is equal to the product of the density of a fluid and the point acceleration due to the gravity and vertical height from the free surface of the fluid. That is small p is equals to rho into G into small into capital Z. Okay, next. Coming to the atmospheric pressure, absolute pressure like that. So the absolute pressure is a pressure. So if you get any small answers question, define absolute pressure. So we have to write this one. Absolute pressure is a pressure in which absolute vacuum pressure is taken as a datum, while gauge pressure is a pressure in which atmospheric pressure is taken as datum. So absolute pressure low, the pressure is taken as, right, in which the absolute vacuum pressure is taken as a datum line, whereas the pressure in which the atmospheric pressure is taken as a datum line, right? So ఇక్కడ gauge pressure datum line లో తీసుకుంటాం absolute pressure కి, but here for a gauge pressure we are taking atmospheric pressure as a datum line. Therefore, P atmospheric pressure is P ABS is absolute pressure is equals to, right, P atmospheric pressure plus P gauge pressure. That is a formula. Pressure, absolute pressure ABS is equals to P atmosphere plus gauge pressure. Next concept is manometers. A manometer is a device. So if I could know in the unit 1, I'm discussing this one. So in the formulas IPND. So I'm discussing this manometer concept. Okay. A manometer is a device. A manometer is a device used for measuring a pressure at a point in a fluid. Okay, glass of water, right? A kennel, water in a kennel, a water in a container, oil in a box like this. So whenever you are taking any container of fluid, whenever there is a pressure point to measure, whenever there is a point to get pressure measured, so that in such cases we are using a device called manometer, right? A manometer is classified as simple manometers, differential manometers, right? Simple manometers and differential manometers. Simple manometers are used for measuring the pressure at a point, while, right, simple manometers are used for measuring the pressure at a point, while differential manometers are used for measuring the difference of pressures between the 2 points in a pipe or 2 different pipes. So there is a difference between simple manometers and differential manometers, right? Differential manometers. Next. A single column manometer or micrometer, single column name మనం micrometer అంటున్నాం, is used for measuring small pressures where accuracy is required. Okay, whenever we require accuracy, specific accuracy, so we are using normal, we are not using normal manometer. In such cases we are using a special type of manometer, that is micrometer type of manometer. Next. The pressure at a point in a static compressible fluid is obtained by combining the 2 equations, that is the equation of state for gas and the equation is given by the hydrostatic law, is given by hydrostatic law. The pressure at any height Z in a static compressible fluid under isothermal compression is P by rho is equals to constant, where P is equals to absolute pressure, Z is equals to Z is equal to height from a sea level, R is equals to gas constant, T is equal to temperature. Okay, now next. The pressure and temperature at a height z in a static compressible fluid undergoing adiabatic compression. So I think this is not there in the syllabus. You can omit. Now, if you see the manometers concept with a simple definition and a problem. So a simple manometer consists of a glass tube, right? This is a glass tube, and one of its end is connected to a point where the pressure is to be measured. Okay, pressure is to be measured, and the other end remains open to the atmosphere. So which one is open to the atmosphere? This is open to the atmosphere, right? So ఎక్కడైతే మనం pressure check cheyalo, that is posed with some this container, right? So here pressure A at point A. So other one is open to atmosphere. Next, the common types of simple manometers are piezometers, U-tube manometer, single column manometer or micrometer. So ఇవన్నీ కూడా మనం యూనిట్ 1లో we have discussed thoroughly and also problems కూడా చేసాం. నేను బ్రీఫ్గా ఫాస్ట్గా ఎక్స్ప్లెయిన్ చేస్తాను regarding this one. So a piezometer is the simplest form of manometer used for measuring the gauge pressures. One end of this manometer is connected to the point where the pressure is to be measured. Okay, so see this figure. The rise of the liquid gives the pressure at head at a point. If at a point A, the height of a liquid, say water, is at h height, then the piezometer pressure at A is equals to rho into G into H newtons per meter square. Next we are taking U-tube type of manometer. Simply here what we are doing, we are doing some changes in the pipe and we are making a U-tube for a design like this. Then a U-tube for a gauge pressure, a U-tube for the vacuum pressure. Gauge pressure ki vacuum pressure. So both are U-tube manometers. A U-tube manometer consists of a glass tube bent in a U-shaped, one end of which is connected to the point where the pressure to be maintained, and other end is connected to the atmosphere. The tube generally contains mercury. So instead of water, we are using mercury or any other liquid whose specific gravity is greater than the specific gravity of a liquid, whose pressure is to be measured. So దీంట్లో వచ్చేసి మనము ఒక లిక్విడ్ మెయింటైన్ చేస్తున్నాం. ఇది వచ్చేసి ఈ కలర్ వచ్చేసి ఒక లిక్విడ్, రైట్? Now, so this is a datum line AA. Now go for a gauge pressure. Please see this one, gauge pressure. Let P is a point to be measured, but P is a pressure to be measured, whose value is P. The datum line is A dash A, AA. Now, to take the considerations, H1, this H1 is the height of light liquid above the datum line. H2, height of a heavy liquid above the datum line. S1 is the specific gravity of the light liquid. S2 is the specific gravity of the light liquid, a heavy liquid. Rho 1 is the specific density of a light liquid. Rho 2 is equal to density of a heavy liquid, right? So like this, we are giving the conditions. Then if you see the problems, the right limb, the right limb of a U-tube manometer containing a mercury. So here the right limb you are getting. So ఇక్కడ మనకి mercury ఉందన్నమాట, right? ఇక్కడ మనకి mercury is open to the atmospheric air. The pipe open to the atmospheric air. While the left limb is connected to the pipe in which the fluid of specific gravity 0.9 is flowing. So ఇక్కడ వేరేది ఉందన్నమాట. The center of the pipe is 12 centimeters. Center of the pipe. So correct, center of the pipe is 12 centimeters below the level of the mercury in the right limb. So below the right limb mercury level is 12 centimeters. Find the pressure on the fluid and the pipe in the difference mercury level is 2 limbs is 20 centimeters. So between these two is 20 centimeters. Now the specific gravity of the fluid is 0.9 as shown. Density of fluid and the rho into S1. That is rho, density of fluid rho 1 is equals to S1 into 1000. That is equal to 0.9 value into 1000. That is equal to 900 kg per meter cube. Next, what is S2? 13.6. Where the specific generally there will be a value into the question value is the specific gravity of mercury is 13.6. Then what is the density of mercury? 13.6 into 1000. Then what is the difference in the mercury level? H2 value is equals to 0.2 meters. Then what is the height of the fluid from AA? Therefore, Height of fluid from A is equals to 20 minus 12, that is equal to 8.8 meters. Next, let P is the pressure to be find the pipe. Equating the pressures A, we get, equating this one, P plus rho into G into H1 is equals to P2 into G into H2. So substituting the values, so substituting all the values, so we are getting P as left one, right side all the values, and we are doing the processing the problem. Finally, we are getting the pressure is equals to 2.597. Next, a simple manometer containing a mercury is connected to the pipe in which the fluid 0.8 having a vacuum pressure is flowing. ఇక్కడ మనకి vacuum pressure అన్నమాట. Okay, the other end of the manometer is open to the atmosphere. So find the vacuum pressure. Same. S1 రాసుకోండి, S2 రాయండి, density of S1 రాయండి, density of S2 రాయండి. Therefore, difference height is 40 meters, that is 0.4. Then height from the datum line is equals to 0.15. Therefore, P you have to find. So thus using the same formula is equals to 0. Applying this to this one, we are getting the P value is minus 0.4. So like this, you have to solve the problems for this manometer concept. So these problems will be for 3 marks or 5 marks. Next, coming to the unit 2. So in the unit 2, we are discussing about kinematics and fluid dynamics. Okay, kinematics and fluid dynamics. So in this fluid dynamics, so we are having what is meaning of fluid kinematics and fluid dynamics. Detail ga nenu meeku information ichchanu, right? What is fluid kinematics and what is fluid dynamics. So here we are having some Euler's equation and Bernoulli's equation, momentum equation, right? And you are having what are the various types of classification of flows. So unit 2 లో మీరు గుర్తుపెట్టుకోవాల్సింది fluid kinematics, classification of flows, right? Continuity equation, fluid dynamics, momentum equation. దానికి సంబంధించిన problems, right? Now we'll discuss these things in deeper. So in the fluid kinematics, we are having how the fluid flow is taking place. Next, we are having the simple definitions like streamline, streak line, path line, and the stream tube. Next, coming to the topic is classification of the fluids. We are having 7 types of fluids. We are having 7 types of fluids: steady, unsteady, uniform, non-uniform, laminar, turbulent, rotational, irrotational, like that. Next, coming to the continuity equation for 1 dimension, 2 dimension, and 3 dimension flows. Next, stream and velocity potential functions. And next concept is flow net analysis. So దీని గురించి కూడా we have discussed already. So సెకండ్ యూనిట్ లో ఉన్న ప్రతి టాపిక్ ని we have discussed. మనం ఏమి కూడా మనము నెగ్లెక్ట్ చేయలేదు, ఒమిట్ చేయలేదు, రైట్? నెక్స్ట్ కాన్సెప్ట్ ఈస్ ఫ్లూయిడ్ డైనమిక్స్. సర్ఫేసెస్ అండ్ బాడీ సర్ఫేసెస్ ఎలా ఉన్నాయి. నెక్స్ట్ వన్ ఈస్ యూలర్ ఫార్ములా అండ్ బెర్నౌల్లి's equation for the flow along the streamline. Next, momentum equation and its applications. Next, force on pipe bends problems. So based on this, we are having some of the formula. So if you are taking the momentum of inertia for a rectangle object, right, rectangular plane surface flow, what is the center of gravity? This is the formula. So what is the area? Rectangle gravity B into D. Then what is the momentum of inertia? CG BD cube by 12. Moment of inertia about the base. So center line ఇచ్చారు అనుకోండి, CG ఇచ్చారు అనుకోండి, we have to take BD cube by 12. Whenever you are taking for the base, that is BD cube by 3. So ఇవన్నీ మీకు క్వశ్చన్లో ఉండదు. So they will see the what type of plane you are using, right? What type of plane you are using. ఆ ప్లేన్కి సంబంధించిన ఫార్ములా ఇవి వాల్యూస్ మీరు ప్రాబ్లమ్స్లో యూజ్ చేయాలి. ఓకేనా? Next one is a triangle. For the triangle, what are the formulas? X is equals to h by 3. Next, what is the area? BH by 12. What is the size? CG? CG is equals to BH cube by 36. Here, BH cube by 12. Next, third one, circle. Third one is a circle. So center from the base is X is equals to D by 2. X is equal to D by 2. Next, area is equals to pi D square by 4. Next, momentum of inertia is equals to pi D id to the power of 4 by 64. So we don't have moment of inertia about the base. Next, for trapezium type of plane, we are using x is equals to this one. Area is equals to a plus b by 2 into h, and moment of inertia cg is equals to a square plus 4ab plus b square by 36 into a plus b into h cube. Next, what are the formulas we are using? What are the small definitions? Like when the fluid is at rest, the shear stress is zero. Means when in a container, when a fluid is not flowing, it is remains still without any very small motion also. Then we can say the shear stress is zero. Next, the force exerted by the simple static fluid on a vertical, horizontal, inclined plane immersed subspaces. So ఇందాక మనం చెప్పుకున్న ఈ ప్లేన్స్ ఉన్నాయి కదా, rectangular, triangular, circular, trapezium planes. When the force is exerted by the static fluid, force exerted by the static, not it is in dynamic, right? So static fluid, either on vertical, horizontal, inclined, like this. F formula, F is equals to force exerted is equals to rho into G into A into H bar. This is the formula. And what is the rho? Density of liquid. Area is equals to area of immersed surfaces. H is equals to depth of the center of the gravity. Next, third one, the center of the pressure is defined as C. The center of the pressure, this one, right? This. The center of the pressure is defined as a point of application of the resultant pressure. Next, fourth one, the depth of the center of the pressure of an immersed surface from the free surface of a liquid. So immersed surfaces ki, vertical immersed surfaces ki, this is the formula, and inclined immersed surfaces kochesi, this is the formula. సో ఈ ఫార్ములా సపరేట్గా రాయాలి, ప్రాబ్లమ్స్ వచ్చినప్పుడు ఈ ఫార్ములా సపరేట్గా రాయాలి. ఓకేనా? సో యూ హ్యావ్ టు కీప్ ఇన్ మైండ్ వెన్ అవర్ సర్కిల్ ఈస్ గివెన్, ఈ ఫార్ములాస్ మీకు మైండ్లో పెట్టుకోవాలి. వెన్ అవర్ ట్రయాంగిల్ ఈస్ గివెన్, ఈ ఫార్ములాస్ మీరు మైండ్లో పెట్టుకోవాలి. ఆఫ్టర్ డూయింగ్ ద వాల్యూస్, దెన్ యూ హ్యావ్ టు టేక్ దిస్ వాల్యూ, ఐజీ వాల్యూ. ఓకేనా? ఫర్ వర్టికల్కి వచ్చేసి ఈ ఫార్ములా, హారిజాంటల్ ఇంక్లైన్కి వచ్చేసి దిస్ ఫార్ములా. నెక్స్ట్, ద సెంటర్ ఆఫ్ ప్రెషర్ ఫర్ ప్లేన్ vertical surface lies at the depth of 2/3 and the height of the immersed surface. Next, the total surface on a curved surface, the total force on a curved surface is given by F is equals to root of Fx square plus Fy square. Okay. Next, where Fx is equals to horizontal force, Fy is equals to vertical force, right? So that is rho into G into A into H. Next, seventh one, the inclination of the resultant force, on a curved surface with horizontal. So whenever the object is having some inclination and it is immersed in a fluid, so we are having some inclination, right? So for that inclination, the formula is tan theta is equals to Fx by Fy by Fx. Fy by Fx. The resultant force for a sluice gate is equals to F is equals to F1 minus F2. Where what is F1? The pressure force on upstream side, and F2 is equal to pressure force on a downstream side. For log gates, P value pressure is equals to F by 2 sin theta, where F is equal to resultant water pressure, F1 minus F2, and theta is equals to inclination of the gate with normal to the side of the log. Next, this unit 2 only, other formulas. The study of the motion, the study of the fluid motion with the forces causing the fluid. The study of fluid motion with the forces causing the flow is called dynamics of the fluid flow, which is analyzed by the Newton's second law of motion, right? Next, so if you get any theoretical question, define Bernoulli's theorem or write the formula of Bernoulli. Bernoulli's equation is obtained by integrating the Euler's equation of the motion. So how you are obtaining the Bernoulli's equation? By integrating, means by combining the Euler's equation of motion, we are getting the Bernoulli's equation. Bernoulli's equation states that, so what it is stating, for a steady ideal flow of incompressible fluid, the total energy which consists of pressure energy, kinetic energy, and datum energy at any point of a fluid is constant. So ఏం చెప్తున్నారు, whenever you are taking two two surfaces is a at position A, at position B, or position C, this is a at point 11, this is a position at 22. So what you are saying here, so we are saying that which consists of a, this is a pressure energy, this one is a kinetic energy, this one is the datum energy, is equal to constant. Atla P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2 is equals to P3 by rho g plus V3 square by 2g plus Z3 is equals to constant. So whereas P1 by rho g is equal to pressure head, V1 square by 2g is equal to kinetic head, Z1 is equals to datum head. Then Bernoulli's equation for a real fluids is equals to P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2 plus HL, where HL is equals to loss of energy between the section 1 and section 2. అంటే ఈ section 1 కి section 2 కి జరిగిన loss energy HL అంటున్నాం, right? Next. So like this, we have the formulas and we have solved the many problems in unit 2. Now we are coming to the unit 3. So in the unit 3, we are having the concepts like laminar flow, turbulent flow. Introduction to the laminar flow and the introduction to the turbulent flow. So we have discussed the Reynolds experiment by taking some fluid entering into some water tank. And then we have seen the characteristics of the laminar flow and turbulent flow. So if you get, here you get 30% problems, right? 30% problems and 30% theory and 70% problems you will get, right? 70% problems, 30% theory. Okay, na? So we'll get this as a theory, Reynolds experiment cheyani, and you will get this as a theory. So give the characteristics. Next we'll see the shear and velocity distributions. What are the laws? This is also a theoretical problem, laws of fluid friction, and how to derive the Hagen-Poiseuille formula. For laminar flows key, who is the person and who is a scientist derived the formula, and for the turbulent flow, who is the person. Okay, na? Next, the flow between the parallel plates, flow through the long tubes, hydrodynamically smooth and rough flows. Second, next part, closed conduit flow. So this is Darcy-Weisbach equation where we are using for the turbulent flows. So we have seen various types of losses, that is minor losses and major losses. Major losses వచ్చేసి ఫ్రిక్షన్ ద్వారా జరుగుతుంది, మైనర్ లాసెస్ వచ్చేసి మనం చెప్పుకున్న 7 ఫ్యాక్టర్స్ ద్వారా జరుగుతుంది. ఓకేనా? నెక్స్ట్ we'll see what are the pipes in series, what are the pipes in parallel, what is the total energy line and hydraulic gradient line. Next we'll see the variation of friction factor with the Reynolds number. We'll see the Moody's chart, pipe network problems, Hazen-Vellius formula, hot cross method. So ఇవన్నీ మనము డీటెయిల్ గా మనము డిస్కస్ చేసుకున్నాము, రైట్? నెక్స్ట్, so from this, some of the definitions and formulas. A flow is said to be viscous. ఎప్పుడు చెప్తున్నాం a flow is said to be viscous? If the Reynolds number is less than 2000, we will say the flow is viscous fluid. Next, for a viscous flow through the circular pipes, shear stress is equals to tau is equals to minus dou p by dou x r by 2. For a velocity is equals to mu is equals to minus 1 by 4 mu dou p by dou x r square minus r square. Ratio of velocities, loss of pressure head h is equals to this one. Okay, where dou p by dou x is the pressure gradient, r is equal to radius at any point, capital R is equal to radius of the pipe, u max is equal to maximum velocity, u bar is equal to average velocity, mu is equals to coefficient of viscosity. Okay, na? Then what is the capital D? Diameter of the pipe. So these are the notations we have to give whenever you are solving the viscous fluids problems and the turbulent flow problems. Next, coming to the force for a viscous flow. for a viscous flow between the parallel plates వచ్చేసి the formula is u is equals to minus 1 by 2 mu dou p by dou x. U max is equal to 1.5. Hf is equals to 12 mu into mu bar L divided by rho into G into T square. So T is equal to thickness, Y is equal to distance, tau is equals to shear stress. Okay, so keep this in mind. Next, if the Reynolds number is less than 2000 in a pipe, we are calling them as a laminar pipe. And if the Reynolds number is more than 4000, we are calling them as a turbulent pipes. So if the Reynolds number is in between 2000 to 4000, we are calling them as a transition. We are calling them as a transition flow. Loss of pressure head in the laminar flow is proportional to the mean velocity of the flow. Mean velocity of the flow. Mean velocity of the flow, which in case the turbulent flow is approximately proportional to the square of the velocity. Next, expression for the head loss by using the Darcy-Weisbach equation. Head loss HF or HL ఏదైనా తీసుకోవచ్చు. HF is equals to 4 into F into L into V square divided by D into 2G. Okay na? So where F is equal to coefficient of friction, right? Then that is equal to F into L into V square by D into G, where F is equal to friction factor. So L is equal to length of the pipe, V square is equal to velocity, D is equal to diameter, G is equal to gravity. Therefore, the coefficient of the friction is expressed in terms of shear stress as 2 tau naught by rho into V square, where V is equal to velocity, mean velocity, P is equal to mass fluid density. Next, fifth one, shear stress in a turbulent flow is the sum of shear stress due to the viscosity and shear stress due to the turbulence, that is tau is equals to tau V plus tau T, where tau T is equals to shear stress due to viscosity, tau V is equal to shear stress due to viscosity, tau T is equal to shear stress due to the turbulence. So that is a ratio. So these formulas what I have written and given for you is also very important for the various types of flows. So tau is equals to rho into U dash into V dash. So U and T, V and T fluctuating components. Therefore tau is equals to rho into U into V dash bar. That is the turbulent stress, Prandtl mixing length. So this is the formula for the Prandtl mixing length. Next, velocity distribution in a turbulent flow, tau is equals to rho into K into Y squared into du by dy square. Okay. Next formulas. What is the Darcy-Weisbach equation? This is the Darcy-Weisbach equation. Okay. So the Reynolds expression for the stress. Reynolds expression anti tau R is equals to rho into U dash into V dash bar. Prandtl equation, velocity distribution, Reynolds roughness number, U star into K by V, velocity distribution in smooth pipes is equal to this one. Next, velocity distribution in the rough pipes is equals to rough pipes ki oka formula untundi, smooth pipes ki oka formula untundi, right? Next, for this one is equals to U by U star is equals to 5.75 log 10. Velocity distribution in terms of average velocity for smooth pipes. For smooth pipes, this is a formula. For the rough pipes, this is a formula. Difference in the velocity is equals to that one. Coefficient of friction is given by various types, depends upon the laminar flow. Laminar flow ki F is equals to this one. For the turbulence for smooth pipe, F is equal to this one, right? So for this one, F, whenever this is in this range, FL, so generally you manaki maximum undadu, right? So we'll get these two values only, maximum this two and occasionally this type of formula for the rough pipes. Okay, for a smooth pipes kochesi ee formula, for rough pipe kochesi ee formula. Turbulence shear stress by the Reynolds number is given by, so already cheptunnamu, expression also said. So this is also given velocity distribution, this units. Velocity defect is the difference between the maximum velocity and the local velocity at any point. Mu max is equal to this one. Next, the boundary is known as a hydrodynamically smooth if K average height of irregular projects preparing for the surface of the boundary is small compared to the thickness of the laminar supply air. The velocity distribution of for the turbulent flow, U by U star is equal to 5.75 log 10 into U star by V by into V plus 5.55. Next, velocity distribution in terms of average velocity is equals to ఇందాక మనం రాసి ఇవన్నీ చూపించాను మీకు. ఓకే, నెక్స్ట్, if you know the energy loss in the pipes is classified, any losses ఉన్నాయి energy losses in the pipes లో two types, one is major energy, other one is a minor energy loss. Major energy loss అంటే ఏంటి? Major energy loss is due to the friction, while minor energy loss is due to the sudden expansion in the pipe, sudden contraction in the pipe fittings, pipe bends, and obstruction in the pipes. Next, energy loss for the adhesive HVAC equation is equal to this one, right? For the major friction losses, we can use this formula as well as Cesi's formula, that is V is equal to C into root M, right? So these are their units regarding those formulas. Next, loss of head in the sudden expansion. Expansion వచ్చేసి this formula. Expansion, say formulas మీరు by head చేయాల్సిన తప్పదు. Expansion వచ్చేసి ఈ formula. These are V1, V2, this so on so. Then for sudden contraction, so sudden contraction ఉందనుకోండి, sudden contraction, the formula is HC. Okay na? Next, if CC is the coefficient of friction, what is the formula? This one. Okay, this one. The loss of head at the entrance of the pipe HI is equals to this one. Next, loss of head at the exit of the pipe H naught is equals to V square by 2G. Then we are having a small for definitions like hydraulic gradient line and total energy line. Right? The line representing the sum of pressure head, datum head is known as HGL, when the sum total accepting the pressure head, datum head plus velocity head, velocity head with respect to some reference line is nothing but TEL. So the siphon tube, so we don't have this one. Maximum siphon, no, we don't have this one. We will have one more, no problem. Next, the equivalent pipes గురించి మనం చెప్పుకున్నాం కదా. So for this one, the formula is this one, where L is equal to equivalent length of the pipe L1 plus L2 plus L3, D is equals to D1 plus D2 plus D3. Next, for solving the problems, the power transmission గురించి కూడా ప్రాబ్లమ్స్ 2-3 చేసుకున్నాము. దానికి సంబంధించిన ఫార్ములా, దానికి సంబంధించిన డిశ్చార్జ్, రైట్? సో దిస్ ఇస్ ఎఫిషియన్సీ ఆఫ్ ట్రాన్స్మిషన్ త్రూ ద పైప్స్. ఎఫిషియన్సీ, ఈ ఫార్ములా కూడా మనము ఆల్రెడీ దీని మీద ప్రాబ్లమ్స్ చేసుకున్నాము, దీని మీద ప్రాబ్లమ్స్ చేసాము. సో వీ డోంట్ హ్యావ్ దిస్ వన్, రైట్? నాజిల్ గురించి మీకు లేదు, వీ డోంట్ హ్యావ్ దిస్ వన్. Next, so like this, we have used various formulas to compute the problems in Unit 1, Unit 2, and Unit 3. So with this, I will stop the class. Hope save this topic. I will send this PPT also. So these are the formulas where you come across for the 3 units, right? So we'll discuss from next class onwards, Unit 4 and Unit 5, right? So thanks for listening to the class. Have a nice day.